minus one of the intercepts, x minus another of the intercepts, and this is another case where you switch the signs. Anytime anything is inside the parentheses with the x, there's probably some sign switches going on. Yes, Jordan?
Because there's so many different formulas to remember.
3.
No, all the stuff prior to this.
You mean like for the whole year? Just this unit. For parabolas, we're only looking at, well, if you include that, there's 3 different ways to write parabolas. Standard, intercept, and vertex. Then there is the quadratic formula, and then there's the process of completing the square. Yes. Pardon? I'm not sure. I want to see if Ms. Lewis got to it while I was out.
No, she's not.
Okay. All right. Well, here's what happens with this. If I tell you, hang on, that a parabola passes through the point, this is what I'm finding out, passes through the point 412, okay? And the intercepts are at -8 and 2. Remember what we did to find intercepts? And who thinks they can work backwards to this? Remember what we did to find intercepts back in December, Amanda?
Fine.
Well, we know the intercepts now. I'm asking you to work backwards and find the equation they came from.
Plug it in.
Plug it in. Okay, what happens when you plug it in?
Wait, no.
Well, as long as I keep this as minus, that's not good. I apologize, man. That wasn't my best question. Nimi?
Wait, I thought to find the intercept would be y1 multiplied by 2 over.
That's fine. You're back in lines today. You're going back to lines. It doesn't have anything to do with parabolas, unfortunately. Okay, if you're given the intercepts, that's your A and that's your B. So now it's y equals A times x minus -8 times x minus 2. Okay? All right?
Can we not have 2 A's?
Yeah. Can you put C?
You want B and C instead?
Sure.
But then there's A, B, and C. See, this A is actually the same as the A in standard form. That's a good point. How about M and N?
Yeah, that was our original, wasn't it?
I think so. You know what? I think that's what okay. M and M, then, because this A will actually always be the same A as AX squared plus BX plus C. This A will always be the same A as AX squared plus BX plus C. That one would not have been, so thank you. That was a poor choice.
Wait, I have one question.
Yes?
Would you plug in the 4 and the 12 where the A and the Y is?
No. Hold that thought, though. Now I make that positive, so it's y equals A times x plus 8 times x minus 2. And now I need to find my A value. Now, Nimi was close. What do you think I plug in where to find my A value?
I know.
Nimi?
Would you plug in the 2 where the Y is and the -8 where the X is?
No, these are both x coordinates. These are intercepts. But I did say that the parabola passes through this point. And this is an xy coordinate pair. Yasmin?
Sorry. No,
Exactly
12
wrong.
Y.
This is an xy coordinate point. Yep, 12 into y and 4 into x. And that would tell me my A.
It's what I meant, but I had the wrong set of numbers.
Correct. You did have the wrong set of numbers. So now this is 12 equals, and please make sure I do this correctly, A times 4
No.
plus 12.
It's
4
8.
plus 8.
Thank you. Excellent.
Did you do that on purpose?
No, so I'm glad you, I would love to say that I was testing you. You know what I was doing is I was adding 4 and 8 together in my head.
Why do you
And
have
jumping
another
ahead.
4?
And 4 minus 2. Now, what's your question?
Why do you have another 4? They only plug it in once. Well, I know
You
there's-
plug it in for every x. How many x's do I have? Okay, so that's why that showed up twice. So now this becomes 12
2.
equals A times 12 times times positive 2.
Which is 24.
Yep, 12 equals A times 24. And Claire, what's that? What's A going to equal?
12.
Exactly, 1/2.
What?
2.
Nope, you divide both sides by 24, Jordan. And you wind up with A equals 1/2, which means your final answer is that Y equals 1/2 X plus 8 X minus 2.
That's
Okay.
not that hard if you think about it.
It's not bad. There's a lot of numbers to keep track of. I mean, Jordan does have a point. There's a lot to keep track of on these. But
The equation.
I'm kind of testing you on your ability to keep track of them, Jordan.
Is there a class
We'll discuss that more Monday. If I do that, I'm going to make it a harder test.
No.
So
If we do what?
guys, we'll discuss that Monday. The test will be Tuesday. Okay.
If we do what to make an article?
Give you equation sheets.
Oh, wow.
Give you a cheat sheet. Okay, so now last thing, and this will be okay.
My clock's broken.
Yeah, I was about to say.
Okay, wow.
It's ticking back.
All right, somebody needs to tell me when we get close to 9:40, but
Okay.
It's 9:18.
9:18.
Yeah.
Oh, actually, we're doing really well.
It takes, yeah.
Actually, it's taking forward and backwards. What it's doing
What?
is the
Fighting itself.
no, the motor is it is the motor is trying to lift it, and gravity's pulling it back down. And the motor's so weak it can't lift the second hand right now.
Yeah, aren't you so smart?
Oh, I could be wrong. Why do I doubt the sincerity of that? Okay. Now, last thing, and this might take the longest, but we talked about it a little bit yesterday. Okay? Right? The quadratic equation.
Can you erase this on the other side?
I can erase this, but the Mr. Singer's neat tricolor stuff is helping two of my classes, and something else we're doing multi-day.
Is it your pre-cal?
Yes. Write the quadratic. You'll know what most of that means by the end of this year.
No.
Write the quadratic equation of the parabola
That looks like a T.
which
Where?
passes through. Is that better, Jordan?
Yeah.
Passes
Beautiful.
through the given points. Okay? And I'll pick the points from this example so that hopefully the numbers won't be too ugly. 1, 1, 0, -2,
Is this the 3? Oh, man.
2, 8. Yes, this is the one that gets you a three-dimensional linear system.
Oh, this is Kramer's rule.
Well, Kramer's rule can help. I can show you a faster trick. There's actually about 17 different ways to solve linear systems, and there is one of them. I didn't teach you the absolute fastest one on the calculator because I wanted you guys to learn determinants of matrix and Kramer's rule. Shade, if you have to do that again, stifle it or leave the room. It's way too loud and annoying. There is a faster way to solve these matrices. Okay? And here it is. But first, we got to set up the matrix correctly. If you can't do that, you won't get the right answer no matter what. All right? Now, what was the trick that you were shown to do to start this off?
No.
No.
Plug it in for what? Okay, Sade's telling the right formula to start with. Y equals ax squared plus bx plus c. Okay?
Now you plug it in.
Plug in what, specifically?
The point.
Oh,
Yep.
right.
Plug in the points for x and y, and you'll be left with equations with a, b, and c.
It all works out.
So this is going to be 1 equals a times 1 squared plus b times 1 plus c. And then we get another equation, which is -2.
It's
But
the
how does
other.
that-
the other
Yeah, this one.
things.
Yeah, you really messed up things.
Where did I mess up?
Numbers homework.
No. He's writing out all the he's plugging in the coordinates. He's not just.
Hi, Amanda.
Never
What
mind.
are you talking about?
Never mind. You want to continue with your
That's the
own
smartest thing you've said today.
Thanks.
All right, and now we have 8 equals a times 2 squared plus b times 2 plus c. And now at this point, I would welcome anyone commenting or pointing out any errors I've made. I'd rather you point it out now, please. At this point, I'd love to. Once I've finished. Yes, your question.
I'm confused. Why do you have C like by itself?
Because there's no x after it.
Because
There's no x to multiply it by ever.
Oh, so that's what I'm going to plug into my calculator. C.
Wow.
I'm asking you.
You were really rude.
No, you know what, Amanda? I find the learning process is really sped up and help. If you wait until you've heard something but don't at all understand it, and then you get confrontation. I think that's fantastic. Can you do that every day? I'd love that, please.
Sure.
Okay, thanks.
You're
All
welcome.
right.
All right.
Keeps me on my toes. All right.
we can solve this
Now,
by doing this.
in a minute here. Here's what we're going to... Okay, now. Yasmin, yes.
For each step, do you change the line? Keep changing the line.
What I did is I plugged in 1 for y in this